NASA has discovered an asteroid that now holds the record for the highest probability of impact ever detected. They declared it as 3.1% on the 19th of February. That is a 1 in 32 chance of a collision. And this asteroid is massive, about 60 meters tall, and if it did hit Earth, the collision would release about 8 megatons of energy. That's over 500 times more than the atomic bomb dropped on Hiroshima in World War II. The chances of an impact are still relatively low, but over 100 million people live along the risk corridor in cities that could be completely destroyed by the impact. We do need to take this event seriously, but I don't think you need to be completely terrified, at least not yet. There is a system known as Atlas that uses telescopes in Hawaii, Chile, and South Africa to scan our night sky multiple times every single night looking for one thing: dangerous asteroids. On Christmas Day last year, the system was automatically scanning the skies as it does every night when it suddenly found something. An asteroid had just passed 830,000 kilometers away from Earth. If the Earth is here and JWST, our most powerful telescope in space, is here, this is how close the asteroid passed. About twice as close as JWST. A bit too close for comfort if you ask me. This set off alarm systems all around the world, and countless ground-based observatories started working around the clock to try and analyze this potentially dangerous asteroid. By looking at how much light is reflected by the asteroid, we can get an idea for how big it is. This tells us the asteroid should be about 40 to 90 meters tall and traveling through space at nearly 50,000 kilometers per hour. We think the asteroid is made of rock, which would be the best case scenario, but we need better data to be sure. Right after its discovery on January 27th, it was given a 1.2% chance of hitting Earth. This then increased, and by February 7th, it became 2.3%. 10 days later, things got worse again, making it 2.6%. And finally, just a few days ago, on February 19th, it broke the records, reaching a peak impact probability of 3.1%. This makes it the asteroid with the highest chance of hitting Earth ever detected in history, a 1 in 32 chance. But this is what we should be expecting to happen. The probability of an impact should be changing all the time as we get better data. And lately, the full moon has made it hard for our ground-based observatories to even look at the asteroid. Now, since then, it has dropped back down to around 2.8%, which is actually still higher than the previous record holder, Apophis, which reached 2.7% back in 2004. Interestingly, it actually also has a 0.8% chance of hitting the moon instead of us. We would probably even be able to see it smash into the moon from here on Earth. But I know what you're thinking. The burning question is, what if it does hit us? This is the impact corridor. Using our best simulations, we can tell that the asteroid will hit somewhere along this line if it does collide with Earth in 2032. More than 100 million people live in cities along this terrifying line as it intersects with major population hubs like Mumbai, India, Dhaka, Bangladesh, Lagos, Nigeria, and Bogota, Colombia. It could also destroy the Panama Canal, an important trade route that 5% of all global trade passes through, potentially causing crippling delays to the global economy. So how bad would it be? Well, it really just depends on what the asteroid is made of and where it actually hits. Around half of the risk corridor lies along the Indian and Atlantic Oceans. If it did crash down in the middle of the ocean, that would be the best case scenario. Minimal local tsunamis would be generated and mostly everything would be okay. But what about the worst case scenario? In that case, the asteroid would hit a major population center. Let's take Mumbai, India as our example because it really could actually hit there. On the 22nd of December 2032, around 7:30 PM in Mumbai, the asteroid would enter the atmosphere, traveling at an astounding 17 kilometers per second. It's carrying with it 7.8 megatons of energy, equal to over 500 atomic weapons. If it were made of stone, it would start to break up around 58 kilometers above Earth's surface. This makes it into a cloud of rocks falling towards the Earth at 5 kilometers per second. Some of these rocks are bigger than cars. 40 seconds after impact and the air blast will arrive. Wooden framed buildings would be crushed. glass windows would be shattered, and about 50% of all of the trees in the surrounding area would be flattened. But if the asteroid is made of iron, the story is much worse. The asteroid would make it to the ground, mostly all in one piece, and strike the Earth with 5 megatons of energy. This would create an impact crater 1.3 kilometers wide and 300 meters deep. 2 seconds later, earthquakes in the surrounding areas would be triggered, and 30 seconds after impact, the air blast would arrive. These winds would destroy pretty much all of the remaining buildings, and 90% of all of the trees in the surrounding area would be flattened. Because Mumbai is so densely populated, the endangered population would be over 15 million people. Even the most conservative estimates would place it at millions of fatalities upon impact, making it the most destructive and catastrophic event in human history, far surpassing even natural disasters and global conflicts. I get asked hundreds of times a day, how do I become an astronomer? So let me let you in on a little secret. A huge amount of our time as astronomers is spent coding to run simulations and analyze data. It took me literally hundreds of hours to learn how to code like an astronomer in Python, but it doesn't have to be that hard. There is this genuinely amazing service called boot.dev that makes learning how to code into a game, and I'm not kidding when I say it's addictive. You start by learning the basics of Python in the best way possible. They guide you through writing a text-based interactive game called Fantasy Quest. As you complete tasks, you'll gain XP, level up, and earn rewards. And once you're good enough, you'll even get to build your very own Asteroid game like this. Just please trust me when I say this is honestly the best way I've found to get started learning how to code. And here's the best part. There is literally no risk because they offer a 30-day no questions asked refund policy. So just try it out and I'm sure you'll love it. This could be your first step towards a career in astronomy, so don't miss out. Just sign up with my code AstroKobe and you'll get 25% off your first year when you select their annual plan. Okay, now take a deep breath. I know what you're thinking. When will we know for sure if it's going to hit us or not? Here's the thing, the asteroid is currently flying away from us, and after April it will be too far away and too faint for us to observe. So really, we have 2 months left to observe this asteroid as much as we can and gather as much data as possible, otherwise we won't be able to see it again until June 2028. In 2028, it will come back around and pass close to us again. Our last look at the asteroid before it potentially swings back around and hits us in 2032. Because of this, the JWST team was granted emergency access to observe the asteroid in March to give us a better understanding of how big it really is. If we were alive even just 50 years ago, we would have no idea that this asteroid even exists. So isn't it amazing that we have telescopes looking out into space protecting us 24/7? And what's crazier, even just 20 or 30 years ago, if we did detect this asteroid, we would have no idea what to do to protect ourselves if we needed to. But now, we do have some plans. Nuking the asteroid is of course dangerous because it could cause it to break apart into rubble, potentially making it even more destructive. Not to mention how politically difficult it would be to launch a nuke into space. You could actually use lasers to vaporize the surface and push it off course, but that technology hasn't even been tested yet. But do you know what has been tested? DART. Back in 2022, NASA tested the first method of planetary defense against asteroids. They did this by smashing a spacecraft literally right into an asteroid, causing its orbit to change ever so slightly. Now, 3 years later, some people think we need to make another to use it on this asteroid. But would it even work? Well, for starters, the DART asteroid Dimorphos was much bigger than this one, and we can do the math. We would need to wait until 2028 to launch something like DART, because that's the next time the asteroid makes a close pass-by of Earth. The collision will need to change the velocity of the asteroid by about 0.02 meters per second to ensure it misses the Earth. So, doing the math, it turns out if we can get a spacecraft to make a head-on direct collision with the asteroid traveling at about 13 kilometers per second, it would only need to weigh about 200 to 500 kilograms to knock it off course. And that's well within our capabilities. DART itself weighed about 570 kilograms when it hit its target back in 2022. So don't fear too much. If we needed to, we absolutely could save people from this terrifying event. I just want to quickly jump in at the end here to let you know that NASA have made new observations of this asteroid since I filmed the start of this video. The chances of this asteroid hitting Earth have now dropped to around 0.004%. That's about 1 in 25,000. Interestingly, the chances of it hitting the moon actually went up to about a 1 in 59 chance. But there's nothing to stress about there. It most likely won't hit Earth, and if it did hit the moon, we would be fine.